Hello and welcome to this sixth tutorial on 8085 programming, and the topic of today is HL pair as a pointer and related concepts. This is a very small program, and the purpose of this program is to load some data from memory. Suppose I have kept some data in my memory from 2 to location number 7. I have kept this random data. I have entered it manually, and in the first program what we will be doing is we will be accessing this memory location 0002H or 2 in decimal, and the data which is kept at this position, it will be taken inside the accumulator, and then after that it will be incremented by 1, and then the data will be stored back to this location. So this 4 will be converted to 5. We have done this earlier by using LDA and STA commands, and today we will be doing it by using HL register pair as a pointer, and there are certain advantages to it that we will see after understanding this program. So in HL register pair, that is, this HL pair is written together because it has a specific reason. This HL registered together can be used as a pointer. Means suppose the address of this memory location happens to be 0002H. If I kept these higher two numbers in H and these lower two numbers in L, then this complete address 0002 is kept in HL register pair. Remember, it is in hexadecimal. Now if an address is kept in this way in HL register pair, then I can imagine a hypothetical register M, and I can treat it as these registers A, B, C, D, E and HL. So that hypothetical register will have contents which are equal to the contents which are placed at this memory location, and reading and writing operation from this M register will be similar to the other registers A, B, C, D and E, HL. So now I have used this move command, move A comma M. So this will move the data which is kept in M to register A. Remember that the data is moved in backward direction. The data transfer will be from register M to register A, and this is a copy operation. It is not a cut operation. That is the data from M will be copied to A, and after copying, this M will also retain the same data. Now what is the data which is placed at M? The data which is placed at M is that data whose address is 0002. So at this address we have this 4 data. So by this command, this data will be moved to A, and after that ADI01H will increment the accumulator by 1. We have already seen similar commands in earlier tutorials. So this AD is for addition, I is for immediate data, and ADI will increment the accumulator by 1. So we have moved the data value of 4 here, so it will be incremented by 1 and it will be converted to 5. Then move M comma A will move data from the accumulator to this M register, and M register is the register whose memory address is now 0002H. This is a special hypothetical register in which we have kept our data, and after the execution of this program, since M corresponds to this location, so this will be changed to 5. So we will see the step-by-step execution of this by pressing the key F5 every time. So if you will press the key F5 every time, we will be able to see the execution of every command. So I have pressed F5 for the first time, and I have moved on to this location. Now if I will press it again, a value of 00 will be moved to the H register. So H is already having a value of 00, that is why it is not apparent, but 00 has been moved here. Now if I will press F5 again, 02 will be moved to L register. So I have pressed F5 again, and 02 is moved to this L register. So complete address 0002 is here, and then I will press F5, so the data from this M will be moved to A, and since M now becomes this location because the address is 0002 is kept in HL, so that is why the data 4 will be moved to register A. I press F5 and this data is moved here. Now again I will press F5, so the accumulator will be incremented. Accumulator becomes 05 as you can see here, and after this I will execute this command move M comma A by pressing F5, so the data is moved to this location, and now you can see that instead of 4 we have 5 here, and halt will stop the program. Now this same thing was done in earlier video tutorials by using these basic commands: LDA 0002H, which will load the accumulator with the data which is kept at this address, which happens to be 4 earlier, and then ADI01H will increment it, and STA0002H will store the data, and halt will stop executing the program. So what is the purpose of doing all this? Now see, there is one purpose. Suppose I have multiple data in memory, multiple data in memory at consecutive locations or at some random locations. In my case, I have kept data from location 2 to 7 and there are certain random numbers. Now if I want to access them sequentially, suppose if I want to access data from 002, 003, 004 into these basic registers, or general purpose registers, and then I want to add them, and then I want to store the results say at location 000D. So doing this by using these set of commands will be very cumbersome because I have to write LDA and STA 6 number of times. Why? Because the address is immediately provided to it and there is no way by which we can increment this address. So we have not kept this 0002H in some HL pair or D pair or BC pair, so we cannot increment that. And with LDA, the only argument that we can give is immediate data, means we cannot specify any register pair here. So that is why this LDA and STA will not work for that, and that will be very cumbersome to write this code. In this case, there are only 6 entries, so you have to write this 6 times and this 6 times. But if we have 1000 entries, then that will be very cumbersome. So for that purposes, HL register can be used as a pointer. So now let us see an example where we will be adding all these elements from memory location 02 to 07 and we will be placing the result in 000D. So let us first of all reset the registers only. So if you will reset all the registers and we will reset all the flags, so this complete region will be cleared. Do not reset memory because otherwise this data will again go and you have to enter it manually again. So we have reset registers and flag, which is sufficient. So now I am changing this program. I have already written this program and saved it in my hard disk. So this is the program that will be required for our purposes. So here the thing is same. HL register pair holds the initial address 0002H, and since there are 6 data items from 002 to 007, so I have initialized a variable inside register B and I have kept a value 06H. So I will keep it decrementing till it becomes 0, and I will keep this HL register pair, I will keep incrementing HL register pair so that I will be able to access this consecutive locations inside some loop. And the result of calculation will now be stored in E. So I will intentionally store it in E because A register will be busy in doing all sorts of calculation. So I will, on safe side, I will keep my result in E register, that is at this location. And you can see at the end of the code that after this code has been executed, this E register will transfer the data to the accumulator, and through the STA command at 000D location, that is at this location, our data will be stored and then the program will be halted. So today we have to first see how to write a loop. Means since we have to access this memory locations consecutively and we are performing same operation again and again, so we can write it inside a loop. So how to write a loop? You just define any name. I have defined a name label 1 and then I have put colons here. So now this can be anything. This can be your name also, or this can be anything. And this label has there should be a statement after this label, means you cannot leave this blank. You have to put some command here which will be executed, and at the end of the loop you have to write JNZ label 1. JNZ means jump not 0. Jump not 0 means if the execution of the previous command happens to be such that 0 flag is not set, then you have to jump to this label 1 again. Similarly, we can also have a command jump on 0, that is JZ command is also there. There are several other commands that we will look after, but JNZ means jump not 0. That means when the results from the previous command is such that this 0 flag is not set, then you have to move on to the label again. So this is how a loop is designed in 8085 programming. Now which command will be considered? So the immediate command, which is before this, move B comma A, this is a data movement command. So this will not affect any flags, because we know that flags will be affected only when there is certain operation. So this SUI, that is the subtract immediate data from accumulator, will be affecting the flags. So the result from this command will be affecting the flags, and whenever this result is such that the flag is not set, the loop will be run again. So let us see here. What we have done is, at the starting of the loop, I have moved the data from M to A. Now what is this M? M is a hypothetical register and this contains the data which is kept in this contains the data, the address of which is kept in HL pair. So at location 0002H we have data 5, so M contains 5, it is moved to accumulator, and then I am adding E to the accumulator. ADDE will add E to the accumulator, and then the result of addition will be again stored into E. So move E comma A will store the result of addition to E again, and then I am incrementing L. So by incrementing L, I mean that HL register pair will be incremented. H is in any case 0 and L is 0, 2, and we have to move to 0, 7 only. So there is no point of incrementing H and L together. We can only increment L and we can get our job done. So INR is the command which is used for incrementing, and this L will be incremented by 1 only. And then move A comma B will move the data from B to A. Now what does B contains? We know that B has a counter value of 0, 6. So we have kept it in accumulator, and through the SUI command, that is subtract immediate data 1 from the accumulator. So 6 will become 5, that is counter is decremented by 1, and then this decremented value is again kept into the B counter. So move B comma A will move the data 5 from itself, that is from A to B. So the counter is decremented by 1. So following this procedure, this loop will be executed till this counter becomes completely 0, B counter becomes 0, all the elements will be accessed, and finally the sum of all the data elements will be stored at 00DH location. So you can run this step by step and see the procedure, how the contents of flags etc. and how the contents of the register change. I will execute it only once by execute command or pressing the F9 button, and you can see that 24 is stored and the sum of these all elements is 24. Remember that they are written in decimal only, so you can add them also, it is 24. So in this way, by using HL register pair as a counter, we can access memory locations in the way we desire. So this is all for today, and keep watching our channel because we will be doing more on 885 programming.